Grade 9, how are you, miss? The last lesson that's included in the exam is actually the lesson about the complex number I. Now, or the imaginary number I. Now, as you can see here, I is equal to square root of negative 1. We can take the square root of negative numbers, right? As we used to know. When we were young and still in coordinate algebra or in the coordinate plane or dealing with real numbers, know a number that when multiplied by themselves give us a negative answer. Squaring a negative number always gives you a positive. Negative 1 squared is equal to 1. Negative 2 squared is equal to 4. Negative 3 squared is equal to 9. Now, what the math people or the mathematician did actually, they used the letter I to represent the square root of negative 1, where I stands for the imaginary. Now, as you can see here, I is equal to square root of negative 1. Examples of how we use it in dealing with numbers only, not solving equations. In dealing with numbers, we can say that square root of negative 16, before we used to say that has no real number solution. Yes, it has no real number solution, but there is an imaginary solution for it, or imaginary number solution. I can take square root of negative 1, and say it's equal to I, then multiply it by square root of 16, which is equal to 4. So the answer is 4I. And for negative 81, square root of negative 81, it's the same, equals to 9I. Now, how can we use square root of negative 1? For example, if we are using finding or looking to find square root of negative 45, I can see that immediately I will take square root of negative 1 outside and say it's equal to I. Then I, start dealing with 45, which is equal to 9 times 5. I use 9 because it's a perfect square. Then I say since 9 is a perfect square, so square root of 9 is equal to 3. So I send the 3 outside, and the answer will be 3I, square root of or radical 5. Now, we used to put I at the end, but if there is a radical, no, actually we put first the number, then we put I, finally we put the radical. For example, finding the square root of negative 200, it will be square root of 100 times square root of negative 1, which is equal to I, and 100 and 200 is equal to 2 times 200, so it's 10 radical 10I radical 2. Now, the first 4 powers of I establish an important pattern and should be memorized, which is actually powers of I, which is very important. Now, as you can see here that I to the power 1 is equal to I. Now, I to the power 2 is equal to negative 1, because I to the power 2 is equal to I times I. So, square root of negative 1 times square root of negative 1, which is equal to negative 1. I to the power 3, again, it's equal to negative I. Now, as you can see here, I to the power 4 is equal to 1. It looks like, a rotation, or it looks like a cycle in which, a circle in which you can find, powers of I's easily. Now, starting from I to the power 1 is equal I. Now, I to the power 2, it means that when you squared the imaginary number, and etc.